Okay, so today we're going to be doing a land generation kind of program where it'll create random terrain using Perlin Noise and some other things. So we'll just get started. Start off by making a canvas. Um, we'll just say 300, 300 for now. Just to see where it is, we'll just set a black background. Alright, so we're going to be using the individual pixels for the canvas. So we're going to be using like load pixels, update pixels, and those functions. So load pixels. So that's just for, and we'll put our like pixel where we change the pixels inside of here. And so this will like load them to let them know, okay, we're going to start to change them. Then this is going to update them so it refreshes. So we're going to have two for loops. One for the Y. For the height. And inside of that, we're going to put X. So that'll loop through each individual pixel, starting in the top left and going down to the bottom right. So now let's make a variable called I for like index, and this is going to be storing or used for finding the index of the pixel we are asking to change. So for this, it's going to be X plus Y. So the X value plus the Y value times the width of the window, and then multiply that whole thing by 4, because each pixel has 4 like attributes or parts of the list. There's a red value, green value, blue value, and an alpha value. So that's why we say 4, or multiply the whole thing by 4 so it knows to go 4 for each pixel. So then we're going to say, well, so let's just see if it works. So we'll say pixels, pixel I equals, so we're going to set the red value to 200. We'll set so we'll say I plus 1, so this is accessing the green value, to 100. Then pixels I plus 2, this is accessing the blue value, so we'll say that 30. And then for the alpha value, we'll just set that at 255. So if we load this, you'll see we get a changed background. So this is basically if you want to change a background, like the background, that is basically what's going on when you say background. If I can spell it. Like background, then you put in the colors. That's the values. That's what this is. It's just written out. So what we can do is we can do some interesting stuff with this. We can say why don't we do map X 0 to width 0 to 255. See how that looks? So that's cool, and we can do that. Let's put this one for the Y. So you can really get some like gradient colors in with this, so it allows much more like creativity than using the background function. And we're going to be using this with Perlin Noise, so we can get so we can integrate those both to get a terrain. So for now, let's going to make a variable called color. Make this a array or a list, with just the color values. Oh, 2000, okay. And we're going to say, so this is just going to be an easy way to access what we have. So this will do the exact same thing. It's just going to be more organized for what we're going to do later. Okay, well it's white because, there we go. So you just change the items inside of the list to change the color of whatever you were going to be drawing. So now let's put in some of the Perlin Noise stuff. Okay, so we'll just set this to 0, 0, and we're going to make two variables. Oops. So the x, I guess it's like an x counter. We'll set that to 0, and a var y counter, set that to 0, and then we need one more variable just to keep it clean for how much we want to increase the counters for the Perlin Noise. So we'll call it like no, we'll just say that, and we'll set it to, so this is the value that you can change to make it the noise smoother or more aggressive, I guess. So we'll set it to just that for now, and we'll mess around with that later. And then what we want to do is inside of the y, let's actually just say that. We'll just create, so we're going to, inside of the y loop, but not inside the x, we're going to say x counter equals 0. So we're going to reset it for every like y. Every time the y loops, it's going to reset the x counter. And then inside of the x for loop, we're going to say x counter plus equals inc. So it's going to add the increment to the counter. And at the end of the y loop, outside the x loop, we're going to say y counter plus equals increment. So that's just going to update the y increment every time it goes to a new row, along with resetting the x counter. So now, instead of saying the color is white or black, we're going to add in the noise. So we're going to say, did I say n? Probably not. Okay, so n equals noise x counter. So we're going to pass in the x counter and the y counter. And then we want to map this, so we're going to say map. And that's going to give us a value between 0 and 1. So we're going to say 0, 1. And when it's at 0, we're going to want it to give us 0. When it's at 1, we're going to say 255, because we're going to turn this into a color. Well, a black and white color, so on like a grayscale. And then for now, to see if it works, let's just set the color to the noise value. Oh, and then at the end, we're just going to say no loop for now. Oops. So it's just going to loop once and stop. Maybe. Guess not. There we go. It's weird. Okay. So you see we have a smooth transition between our rand. So Perlin noise is a way to get a smooth transition between random numbers. And so you can see how we have it's not all random. It is random, but it has some flow to it. And you can see that because it's kind of mixing in with the other colors or the other shades. So to see this better, let's make it bigger, just for now. There we go. So you can see, and if we want, I can show you if it's, so this is going to be more aggressive, and it's going to be more kind of, looks like clouds kind of, and there's a lot going on. But if we decrease it, then it looks much more smooth. You see it looks like there's nothing going on at all, but that's just because it's really smooth, and so the values change slowly as they go across. So you can start to see, so maybe that is a little too small of a number to see anything really going on. But here you can see some slight changes, and you can see how it's even slower on, or even lighter on the changes. Maybe this. Okay, that's a little high, but I want to show. Okay, so that's smooth, and it's a good example. But we kind of want. I think 3 was a good number. Or for the wait. Let's try 6. Nope. 5. Okay, that'll work. So now what we want to do is, instead of going to the black and white value, we're going to make it look like a terrain. So what we're going to do is, first of all, take out this, and we're just going to say I'll just define it up here. So just in case it doesn't get a value, we'll just preset it with white. And then you'll see this will just give us a white screen. Let's bring it back down to 300. Okay, so now let's start adding colors to it. Before we change the pixel colors, and right after we hit the noise value, we're going to say if so I'm going to set the from 0 to 1 to 0 to 1000, so we can get more like a variety and a precise not measurement, but change, so we can see it better in the numbers. So we're going to say if n is less than 400, we'll just say 500 for now, and color equals, and then I don't really have any good blue values right now, but we'll say, actually hold on, so we'll say, make a variable called small n, which is the exact noise value, and then we'll put small n in, and so we're going to set this to I don't know, we'll just see how that looks, and then we're going to set it to 200, I guess. See how that looks. So now if we rerun it, we should see some spots of blue. So that is going to be where the water is. So that's kind of like the water, but what we want Oh, okay, never mind. Okay, we're going to take out the small n thing, and we're going to say, we'll make a value called n color, which is the okay, we're going to change the name, and then we are going to set a value named n. Probably not the best way to do it. It's definitely not the best way to do it, but this is what I'm doing right now, so we'll just go with it. So n, and then n color is n map n 0, 1, 0 to 55. So that's going to give us a kind of a colored value. Oof, I don't know. This is not going to be what we were looking for, but we'll just see how it looks for now. Yes, we're going to get all crazy colors, which I mean isn't terrible, but kind of would like a better result. Okay, what if you say n times 20? So what I'm trying to do is to make it so you can actually see that some parts get deeper and some parts are shallower. It's a cool effect. So you can start to see it kind of, but we would like it darker, so nope, that's not it. Okay, we kind of get it. We just need to, I want it to be a deeper blue color. Okay, and then just, okay, because I can't see this very well. So for the moment, we're going to make it bigger. Okay, so we'll mess with that later. But actually, hold on. Times 50 times 150. No, 50, yeah. Okay, no, that's fine. So let's make it even less so we can see more. Nope, not that way. Wait, what? Oh, okay, so then let's just lower the to about 300 so we'll get more land. What the heck, that's so weird. Oh, wait, hold on. I think I know what's wrong. Oh, I'm sorry. Okay, so that's looking okay. Don't know why it's looking really awkward in the... Yeah, isn't that interesting? Might have solved it here. Boom. Okay, I guess I cannot stand that. So if n big is... Okay, we're gonna flip this around to start with the... So we're gonna say if n big is less than... Oh my gosh. N big is greater than or equal to 300, and n big is less than 500, color equals, we'll just say, try 70, 8, 70, 60, maybe. So this should give us like a sand kind of color. Not exactly. Okay, we're just gonna continue on until, I think this might fix itself. If n big is bigger than, or greater than 500, and n big is less than 1,000, color equals, say, n, oh wait, no, times 255, and we already have a value for that, don't we? Alright, so you can start to see that there's actually some stuff going on here that is making a terrain. We just gotta fix around some stuff. It's probably been very crazy. No. Okay then. Okay, that's a pretty good value. We're just going to say, let's just make these variables, say water level 300, I guess. We'll say 400. Sand offset, we'll say 200, so that the beaches will be about 150 between the range 400 and 150 or 550. So we're going to say water level plus sand offset. This is definitely not a good way to do this. And then we're going to say 100 or 1,000. So let's increase the water level to about 500 and decrease the sand to about 75. We don't want that much sand. Okay, that's looking good. And you see the oceans have some effect on them, so they look deeper and shallower in other parts. So let's go ahead and try to get these colors so they look more like sand. There we go, that looks nice. So now we have a sand color. We did that by dividing each value by n. So like the lower it is, should have a higher value. The higher it is, lower value, so that's why it makes it light and dark. And same with the grass, as you can see, it looks like it has some height to it, and it has some differences. So we could end it here, but I'm going to try something else I think will be pretty cool. We're going to try to add in a tide. The tide can raise and lower, just like normal tides. It's going to, yeah, I think try to do that pretty quick and then see how it turns out. So the first thing we need to do is we need to make the water level kind of oscillate between two values that we set. So at the bottom of our loop, we'll take out no loop because we do want this to loop now. And it won't do anything right now, but and then what we want to add is we want to say water level equals math dot sign, and then we want to make more variables. We're going to make a variable called counter, set it to 0, and we're going to have at the end of our loops, we're going to say counter. We should probably do this after we do the thing. So we're going to say counter plus equals 5 for now. So we're going to get the sign of, or the cosine of the counter. And then depending on the value, that value is going to be somewhere between -1 and 1. And then we're going to map that between two values that we set for the lowest of the tide and the high tide. So right now, let's just set it to 500, 700. So, okay, so kind of looks random, so let's try to make it the counter shorter. Interesting. So it's moving, and it shouldn't be moving, clearly. Oh, I think I know why. So we need to, at the beginning, we need to say y counter to 0. Set it to 0 to restart it, and then that should make it so it appears like the tide is raising and lowering. We can change the values, and so you know what, let's add one more thing to this. Let's make it, because I don't like how the sand raises too. Let's have the sand at one solid value, and we'll just kind of base everything around that. So water level, we're just going to say sand level. Plus 75. We'll just say that. So the sand, we're going to take out this, and we're going to put in sand offset. Let's see if that works. Okay, so I think I know what's happening. We should just put that first, I think, and that'll do it maybe. Nope, not. Okay, hold on. We just have to think about this. So the sand offset, the number is larger than. Now, why is it doing that? Oh, okay, never mind. So that's probably the green. Water level plus sand offset. We don't need to say plus sand offset anymore. We just need to say water level. Greater than water level. Oh, I don't even need this, do I? Okay, so the sand level is okay. Let's go make another variable. So var. So the starting value, so that's gonna be 500. I'm gonna set that to water start. So we're going to say the sand, if n big is greater than water start, and it's less than sand offset. Whoa, okay, that gives a interesting effect. That it's cool, and I see sand offset. Jeez. Oh, okay. So now we should just move this. And then I think n big is greater than water level. And n big is greater than sand offset. Alright, so now you see that the sand level stays at the bottom of the tide, and it recedes along with the land. So that's pretty cool. You can do more with this. Let's see if we can slow down the tide. Instead of 0.2, we'll put 0.1. See, it's slower. So that's about it for this video. I hope you enjoyed. See you in the next video.